Hello and welcome to another one of D's ADD videos. Today we're going to be looking at an absolute extrema example and a couple relative extrema examples to illustrate the steps that need to be taken for both types of problems. Nothing too fancy, we're just going to do a couple basic ones, but either way you're going to have to find the critical point by setting the first derivative either equal to 0, or you're going to have to do the not differentiable but continuous. If that doesn't make sense, go back and watch a concept video. Once you have your critical numbers, then you're going to either plug them into your original function for your absolute extrema, largest giving you the max, larger or the smallest giving you the min, and we're talking about y values, right? Because when you plug into your original, that's what you're getting is a y value. And then if we're doing the relative extrema, we're going to plot on a number line, do test points on either side of each critical number. If it goes up then down, or down then up, provided it's not an asymptote, then it's going to be a relative maximum respectively. Alright, so let's see this in action. First we're going to do absolute extrema here. So absolute for this one, and in the absolute extrema or in the relative extrema, you're going to have to find your critical points. So we take the first derivative, set it equal to 0. In this case we have a 12x squared minus a 24x. If you can, try to avoid moving the 24x to the other side, because you'll divide out and eliminate one of your critical points. So in this case we have a 12x that is common, and if we factor that out we get x minus 2, and if we set each one of those individually equal to 0, we get x equals 0 and x equals 2. Now you will notice that you have one critical point outside the range, so we don't use that one, and then this one is an endpoint. Okay, so in this problem all we have to do is do the endpoints to test them out. So f of negative 4 would be 4 times a negative 4 cubed minus 12 times 4 squared versus 4 times 0 cubed minus 12 times 0 squared. And reach over here for your handy dandy calculator and you punch all that in. I guess I should have done this earlier, but man, calculators have gotten fancy. I have the TI Inspire here, and this is saying loading operating system. I just need you to work as a calculator. Can I do that? There we are. Where's the cursor? Right and clear. Thank you. Oh, it was waiting on me. Alright, so we got a negative 4 cubed is 64 times 4 is 256, right? Minus a 12 times 16. Actually, this should be it. They're both negative, so it would be summed. That would be a negative 448 for the first one. And that's the y value. And the x value is 0, 0. So in this case we have 0, 0 is the absolute max. And negative 4 comma negative 448 is the absolute min. Now if I would have had a different range, let's say this range was a 4, then this 2 would have been plugged in as well as the 4. F of 4 would be 4 cubed 256 minus, right, so it would be the same entry but a minus sign in between. And that would be 256. This works down, right? 256 minus 192. 64. Alright, so that one would be 64 for that one, and f of 2, a little easier to calculate, would be 2 cubed 8 times 4 is 32, minus 4 times 48. Is negative 16. So, had we changed this endpoint to a 4, then what would have happened is we would have included this critical point, and our absolute min would have still remained this negative 4. Let's see, did our absolute max would have changed, right? This would have been your absolute max. Right, so depending on your endpoints, you can have different maxes and mins, but we're looking for the largest and the smallest. Alright, so make sure you check your critical points are within your specified domain, and plug in your endpoints and your critical points into your original function. The largest answer is a max, the smallest answer is a min.